All right. Looks like we are live. Hello and welcome to the June Stuck on a Bucket webinar. Let's see if you want to go ahead and move a screen or two forward there. I am Fritz Wichern, sales engineer for our Western region here at KMC Controls. And this month I'm joined by Dave Bohlmann, who's our subject matter expert. And he's going to be giving us a little tease of Wireshark captures. So if you want to move to the next slide there, Dave. Most of y'all have seen a little agenda. We're going to look at what Wireshark is, how to capture data, a little bit of what to do once you have it, and a short live demo there at the end. And of course, make sure you stick around and watch your email. At the end of the webinar, one of you lucky attendees will receive a KMC Controls Yeti. Congratulations to Tina Edens with Harrison Energy as our winner last month. So that's that. We can let you go ahead and kick it off, Dave.
Okay, thanks. So we're, obviously today we're going to talk about Wireshark. And so Wireshark is a free tool that is very, very helpful to capture the network traffic that's flowing usually from your PC to other things. You use it a lot of times for internet traffic and that, but we also kind of include that in our BACnet 5051 router, so you can actually capture MSTP traffic as well. The tool in itself provides some statistics on the devices and the messages that's going back and forth. But the main reason we use it is if you have communication problems. Most of the time, all I do is I'll just double check my configurations with my BACnet networks and that, and then I do a shark. I capture the traffic, and I can look at the traffic and see really what and analyze and see what's really going on without trying to guess, and that really helps to troubleshoot what's the cause of your traffic or your problems. There are a lot of tools that you can get that also can capture traffic, and many of them will record that captured traffic in a Wireshark format, and then you can save that and then open that up in your Wireshark and look at it later, and that, so that way you have this one single tool, Wireshark, to be able to analyze what's going on. So, and it's called Wireshark. I have no idea why. That's the emblem. I don't know. So now, what do you need to use Wireshark? One, you have to install it, and I have a few slides later to show you how to install. It's real simple, and like I said, it's free. Then you need to know how to capture the traffic, and that's also real simple. The next thing is understanding where are you going to capture. For internet or Ethernet and that, because of the switches that's out there, the messages that are going back and forth between your PC, if you're using that to capture, and the rest of the traffic or the rest of the network, the switch will block messages that are not destined for you, but they will not block broadcast. So you have to be, if you're trying to see the messages between devices, a lot of times you have to run Wireshark on the other device, like let's say Commander or Total Control or whatever. That way you'll be able to see all the messages. If you don't, you'll just see the broadcast and you'll only get part of what you're maybe looking for. Then you have to understand what you're capturing. Of course, we're going to focus on BACnet here. So you have to know BACnet to some extent, and that can take a little bit of practice, but you do not by any stretch have to be an expert in it. You can catch on pretty quick on what kind of messages to look for. And we'll talk about that more in depth next month as well. And then why we want to capture, well, it's, again, we're looking for patterns of messages or traffic that's going back and forth, and then we know more or less what should be happening, and then you can look for things that are there that really shouldn't be. So we're just trying to use it for troubleshooting again. To install Wireshark, we're not going to do this now. You just go to www.wireshark.org. When you go there, you'll see this splash page here, and then you just click on download, and then you get this pop up. And then depending upon your PC, most of the people just click on Windows 64 installer. And then it'll ask you the normal kind of stuff, if it's okay to install and all that. One of the screens it'll ask you is, here's the different components in Wireshark that you can install. The one that you really need is just this first one. It's just a Wireshark. The rest of them, you can leave it checked or not. We don't typically use it, but just make sure that Wireshark is checked. And then over here, then it will ask you, do you want to upload a MPCap, which is a driver that Wireshark uses, or if you want to update it, and you always need to use it. Then the very last one is, do you want to use USB PCAP, which is a way of capturing traffic on your USB port. And I never do that. So I always leave that unchecked. So, okay. And so then when you start capturing, we're going to do this live here later on, but when you start capturing, you open up Wireshark. It'll show you this screen here as to what the interfaces that you have. You select the one that you want to capture. For me, it's Ethernet 3. And then it pops over here and it starts showing you all the wonderful messages. And sometimes I show people install Wireshark, restart your machine, and then don't do anything. Don't go to a browser, don't stop, or don't start any applications and all that, and just see what kind of traffic there is. And there you'd be amazed at what your PC's doing, and you're not doing anything at all. But that's another issue later. And then to stop Wireshark, there's when it's capturing, this red button will be red, and then you just simply click on it, and then there's a shark icon right next to it. It turns blue, and then it'll stop capturing. So most of the time, I just let it run for 2, 3, 4 minutes, whatever, and then I stop it. It's difficult to analyze while it's still capturing traffic. So you want to stop it, and then you can go back and analyze. So, okay. So the screen, once you, this is the typical screen. I think it's the default screen that you'll see when you're actually capturing. So there's 4 different areas here. One is called the filter panel. So up here on this line, and this is what we'll go into detail on next month. You can, like I said, there's a whole bunch of stuff there that you'll see. So we want to filter, so that way it makes it easier to find a needle in the haystack. And there's all sorts of different filters we can use. This pane here is called a packet list. So each message that Wireshark is capturing is listed here. It tells you the time and who it's from and where it's going, and then also a little bit of information on what that message actually is. And so then we can drill down, we can select one of these messages, and then the details of that show down here, and we can go in and see exactly what's in the message and more information on where it's going and so forth. So we'll do that here in a minute. And then finally, this packet bytes over here, this actually shows you the bytes that are flying back and forth that's in that particular message that you have selected. Most of the time, you can ignore that. If you really want to become a BACnet guru or whatever, then you can look in here and understand that. But it's got to have a lot of coffee to handle that. But so these are the 4 main areas, and we usually just focus on the filter and packet list and the detail, packet detail. Now, sometimes we use the words packet and frame interchangeably, so I might do that here. So a frame is a packet and a packet is a frame. Okay. And this is just, I just wrote up, this is what each of those panes are, again, what their purpose is. And you can adjust the panes, make them bigger, smaller, move them around or whatever. And I think the view that I showed there is really the default view. So, and I like that one. So they do have coloring options. You can color frames depending upon what it is or not, and this and that. And I usually just stick with the defaults because those are pretty cool. So for instance, if you have an internet message or Ethernet message and there's actually an error somehow for some reason in there, it'll show up as a red in there. So that's kind of easy to find. So, okay, now, since we're gonna focus on BACnet, Wireshark has built in, it knows hundreds of different protocols, and so it will understand and start decoding the raw bytes into the protocol that it thinks that message is. For it already knows BACnet, but it only presumes that UDP port 47808 is the BACnet port that you're using. And sometimes, a lot of times, you might be using a different port like 47809 or 80810 or whatever. So what you need to do is tell Wireshark that when it sees like 47809, you want it to decode it as a BACnet frame. And the way you do that is up here, once you stop your capture, up here in the filter, you would type UDP and then hit enter. And then it will only show you just the UDP messages. You can see that here in the protocol there. And then you look for a message that uses, I think this one here is 47828. So you would click on that one. And usually if it's BACnet, it'll be going like from 47800 port to another 47800 port. So you select that, right click, and then say decode as, and then it gives you that list, and then that new port will show up down here, and then you would click on the none and pick VVLC, and then make sure you save it. That way it remembers it for the next time that you capture it and that. So, okay. And let's see. So you have to do that in order to make sure that you're seeing all your BACnet traffic. And then once you've started it and you've stopped your capture, now you want to filter it, and sometimes you want to sort. A lot of times that's just what I do. So if you just, in that filter window, if you just type the word BACnet, then it will only show you the BACnet messages. And again, you have to make sure that the UDP port that you're using for BACnet is in that list that we showed you. So that's if you're doing BACnet over IP or BACnet Ethernet and that. And most of the time when we're troubleshooting, we're only going to be needing to look at BACnet. Sometimes, once in a great while, you might have to look at some of the internet stuff like ARP messages or some other things, and then you can filter for that too. But another thing, though, is if you capture a Wireshark capture using a 5051 router, it's capturing only the MSTP side. And so, and that's only BACnet. So you do not need to do that filter for that. There are other filters, but we'll talk about that here later. And then my second step, once I captured and stopped the capture, and then I filter BACnet, then I usually hit the info label, which is over usually more on the right-hand side, and that just kind of sorts the messages based upon the kind of message that it is. And you can use that to see if you have a whole lot of IM messages or whois messages, or if there are errors. You can kind of get a sense for how many of those there are. And that's usually a decent place to start. You might ask yourself, well, why am I getting a lot of errors, for instance? Or why are there a lot of whois statements or why do I have a lot more who is statements? So a lot of times in troubleshooting, for troubleshooting BACnet, there's really only, I don't know, 6 or 7, maybe 8 different kinds of typical issues that I find, and it doesn't take too much practice to become proficient for that and looking for that. But again, we'll for next month we'll go into that into more details. So, okay, so we've started the capture, we stopped it, we filtered, and then we sorted, see what's going on. And now this is a little bit more detail on the, remember in that packet list frame, it had some labels, and these are, you can sort these if you want, but that, I like the default again. The number here, number label, it's just simply Wireshark will just number each frame as it comes in. So you can sort by that if you want. You can sort by time, and it will show you the time that the message was received. And like I said, you can click on any of these and sort your list by that. The source will either be an IP or an Ethernet address of who sent the message. The destination will either be the Ethernet or the IP address of what we call the ultimate destination. And we'll get into that here in a minute. The protocol, it's whatever the protocol is that Wireshark is using to decode the packet. And that should always be like BACnet. The length is just how long that message is in bytes, just how many bytes it is. And the info is a quick information about that message, and that's also very good for sorting and looking up things. So, okay, and then here, one thing about the time that BACnet, or I'm sorry, that Wireshark will show you is, I think it defaults to the time of day and the month and all that stuff. For analysis, usually it's more helpful to just look at the time relative to the very first frame. And so what you can do then, to set that up in Wireshark, you go to the view, this is the Wireshark main menu. You would go to the view, time display format, and then down here, seconds since the first. And then that way, when you look at your messages, the very first frame is going to be time 0. And then it's going to show you all the other frames in seconds from that one. And that helps. You can tell, for instance, more easily how long, when you see a request for a point, how long does it take for the response to come back? And sometimes that's a hint, that, oh, this is taking too long to come back. So it might be on the device that you need to look at. So I'd recommend changing this. Like I said, I don't think that's the default, but it's easy to change. And you can go back and forth too if you want. So, okay. All right, so then let's say we have all our messages in the packet list, and then we can click on one, and then in the packet detail pane, you'll see something like this. So if it's IP or BACnet Internet or BACnet over IP or anything IP, you'll see something like this. I'm sorry, this is just normal Internet stuff. BACnet IP is a little bit different. So what these are, the very first part here is just information about that frame, like how many bytes it is and that, and then maybe even the time or whatever. And then down here, these are different layers, we call it in the protocols, different layers of the message. So this first one, the Ethernet layer, well, that tells you what the actual Ethernet MAC address is of the device that sent the message, and then also the Ethernet MAC of where it's going to. So, and And then the next one is the Internet Protocol layer, or IPv4, we call it. So this is the IP address of who sent it and then where it's going. So this is an example of when I said the ultimate destination. So what's happening here, this is my machine, 10.110.2.19, and it's ultimately going to this thing, which is a Amazon Web Service. So this server is not on my subnet. So when I'm on my PC trying to talk to that service, it has to go through my default gateway. And so in the Ethernet frame, this Ethernet address is actually the default gateway. So when this message goes from me to the default gateway, the gateway router, then the gateway router looks at the IPv4 part and say, oh, it's supposed to go way out here to Timbuktu, wherever 3.23, wherever that is. And so, and that's what all the routers in the internet are using. They're looking at that ultimate destination here to get your message from you to wherever it is that you're going. The next layer is called the transport layer. This is how devices kind of talk with each other to make sure the message that you're getting all the message, and if part of the message gets lost, they can talk to each other automatically and say, here, I missed part of your message and that. But that's the typical usage for internet and web and that. And they use what's called TCP for that. Some people call it it's a connection or a session. And so what will happen is I'm talking to a web service someplace, again, out in Timbuktu, and my driver, my Microsoft Ethernet driver, and then the driver over there, they're talking to each other and noticing whether or not some of the messages are missing or whatever, and then they'll automatically fix that. And then the actual message that's being sent is in this data part. Now, BACnet IP is a little different in that it does not use TCP, it uses UDP. So that's why we say, you have to configure your BACnet and your devices and that to talk on a particular UDP port. UDP is not a connection session kind of thing. It's what we call connectionless, which means you send out a message and there's nothing in the drivers on those machines for you to really know that it got the message or what it's going to do with it and all that. So BACnet has to add its own handshaking, and that comes in these layers down here. So, and then in BACnet, you have these two layers here, the BVLC, that's where that BVLC comes from. And then this, what's called MPDU. And those two together, they use the BACnet addresses and so forth in order to get your message from where you are to where it's ultimately going. And then when I did the snippet, I left off the last part, which is what's called the APDU. And that is the actual message that you're sending back and forth. So it looks similar, but it's not quite. But this follows what we call the protocol layers, and it is helpful somewhat to understand what that is. For internet and that, there's we call it the OSI reference model. So each layer, in a way, kind of adds its own stuff to your message. Your message is kind of like the letter you're trying to send back and forth, and the layers wrap their own addresses and whatever around that message to make sure it gets from here to there. Normally, these two are the same. The network, that to be TCP, and that, and then we have your transport. Oh, the transport really is TCP, and then finally the application layer. That's what's actually your message. So that's in normal internet, and most of the time you only have to worry about the bottom three and then the top one. For BACnet, in its infinite wisdom, back in the late 90s when it was starting to be defined, they kind of change that layer to this. And so there's really only 4 layers in BACnet. But again, those layers, they kind of get reflected here. It's just in your list here, the layers are kind of upside down compared to what we normally draw over here. But it does help at times to figure out what's going on if you pay attention to what's happening in each layer, to help diagnose your ultimate problem. Okay, so here's an example then. The message is, this is an internet, my web browser example. I'm trying to talk to a DNS server, and my browser says I want the address of www.nasa.gov. And so the Ethernet, so here's that one message. The Ethernet part, this is my PC again, and then this is the default gateway router, like it says there. And then the IPv4 source, this is my IP address, and then this is the DNS. So this is a DNS message. Now the DNS server is not on my subnet, so this MAC address is for my gateway router, and then it sees this and says, oh, I'm going to send this message to this IP address, which is different. And you can tell too by the IP addresses that there's a hint, it's a different network. And then the actual message itself is in this part down here. So what you can do is you can expand all these and look into more details as you want or as you need to. So, okay, now BACnet. Here, this is total controller, converge, or commander saying, give me the value of AV222. So here's my, I did this on commander. Here's the commander Ethernet address. And this is a BACnet IP device that happens to be on the same subnet as my commander. So this is that device's Ethernet address. Here's my commander's IP address, and here's that device that I'm trying to talk to. And I'm using port 47809 and 47808. That shows up there. And then these two down here, BVLC and the MPDU, that's the BACnet addresses to get from me to there. And then this APDU, that's the actual message saying, give me the value of AV222. Okay, and we'll go a little bit more into detail about that here in a little bit. And like I said before, it's very important to know where and when to do your capture. And again, because of Ethernet switches, if you're doing Ethernet, if you plug in your PC into the same Ethernet switch as, let's say you've got, Niagara or running or whatever, the switch is going to filter out any messages that are what we call unicast messages that are not for your PC. So you will miss out on the messages from Niagara or Commander or Total Control to the actual device. You will see the broadcast messages. So there's really only 2 ways around that. If you want to see all the messages, and most of the time you do. One is you can run Wireshark on that machine. Like if it's I don't know how you run it on a Niagara, but on Total Control and Commander, you can run the Wireshark on there. So in other words, or even in Connect, right? If you have Connect open on your PC, so it's behaving like the operator workstation, and then you know you're going to see all the messages that it sees. The other way is not very typical. You can have what we call a smart switch that has a feature called a mirror port, and you can configure that mirror port so that way you plug into that port that you're mirroring, and it will show you all the messages for the other ports if you want. But that's very atypical, and a lot of times IT is not around to set that up for you anyway. So again, just be careful be aware of where you're actually taking the capture from. And then some people forget, you're trying to show me a problem in that. Well, you need to capture while the problem is happening. So what I typically do is I'll start Wireshark, I'll wait 10, 15, 30 seconds, and then I'll try to do the thing that I think causes the problem. And a lot of times that's just like trying to discover or whatever. And then I let it run for 3 minutes or so, and then I'll stop the capture, because most of the time you can figure out what's going on with just that short of a capture. Okay, so now we're going to talk about a real world situation. So I have a Niagara or total control or commander or whatever is no longer seeing the points from a device, and the points do not, and you know that because the points are not updating on your graphics page and that. So, what do we do? Well, do we blame the product? And the audience is supposed to say no. You don't blame the product right away. Do you try to go and find bad wiring or whatever in the network? No, because you're just kind of guessing. Do you reinstall the software? People do that from time to time too. No, you don't do that. Do you blame the new guy? Well, that's a option, I guess. But
yes, you always blame the new guy.
Always blame the new guy. But no, what you really do is you can, at first, you want to, again, do just a sanity check, make sure your BACnet driver or your BACnet routers are configured right. And then instead of guessing, just go ahead and do the Shark. And that takes a lot of guesswork out. And the Shark will, when you read it, you can actually kind of pinpoint more or less where the problem is and be able to more quickly figure out what's going on. So in that scenario, here's my frames over here, frame numbers. This is the time from the beginning of the capture. 44.171 was commander. 44.176 was the device it's trying to talk to. So frame 93 is commander is asking for AV 86, 87, AI 223, and 222. Now here, you can tell it's a request because it has REQ there, stands for request, and confirmed request is commander is demanding some sort of acknowledgement from that device that it got the message. Frame 94, the next one, it's actually an error. So, and you can see it's coming from the device, the 176. So here, right now, I already know that my message is getting to that device and it's actually responding and it's telling me there's an error for some reason. So then commander, and I think total control does this too, and a lot of operator workstations do this, they don't give up easily. And so at first it tried to do what we call a read property multiple, where you can read more than one point in the same message. Some devices do not do that. So then commander tries to read each point separately. And here you can tell it's telling you this is AI 222 and AI 223 and so forth. But you notice each one of them, that device is coming back and giving us an error. It's like, yeah, why is it doing that? So now, so here, this is that same frame up here. So I click on this frame up in the packet list, and I can see right here, if I expand the APDU, this is that very first message. Here's all four of those points it's asking for. And then I select the next frame with 94, which is the error that comes back. And again, I can expand the APDU, and here's the error. It said the device is telling me that point is not there. So now you have to figure out why is it not there. So we have positive feedback from the device. So the message from commander or total control or connect or whatever is definitely getting there, and the device is coming back with a response, and we're getting the response, and it says, for whatever reason, that point no longer exists. And now that's, there's different reasons why that might be. Okay. And then, like I mentioned, you can do a Wireshark capture on the 5051 router. You go to the diagnostics section, do an MSTP capture, and then you would hit start and then hit save. I don't show the save button, and then it will start. You'll see this flying by, and then I usually only let it run for, again, 3 minutes or so. And then you would hit stop and save, and then you can download and then look at that capture. And for MSTP, you'll see things like this. This is actually the devices passing the token back and forth from one another. And that's what you'll see most of the time. This one is somebody's doing a whois. This one's doing a pull for master, and there's a whole set of filters that we can use to filter out stuff and find things. And again, that's what we'll talk about next time here. So that's kind of what Wireshark in a nutshell. My night job, I teach at a college. Been doing that for about 16 years. So here's your homework if you want to play with it. Here are some filters that might be useful, or normally is useful if you want to try it out for yourself before next time. And but we'll again go into that in a lot more detail for next time. And then here's some resources there. So what I thought about, I can show you live for as we do the Q&A on doing a capture in that. Do we want to do that now, or you have some questions first? Or
I don't see any questions yet, so I say we can go ahead and jump in.
Okay, so here is my BACnet router, and then you just log in, and I'm breaking cybersecurity best practice I'm using the default password. So it's complaining about that. So don't do what I do, just do what I say. So I tell my students that all the time, and they laugh. Anyway, so here's our BACnet router thing. You come down here to diagnostics, and here's your token use, and that's helpful too. The 77 is my BACnet router's MAC address. The green, of course, are the devices that's talking to, and then you can see the token go around. But if I want to capture, I just click on capture here. You say start now and save. And then I usually take a couple swigs of my coffee, and it's not enough time to have a cigar. It's just, let it run for, we're not going to let it run all the time here, but, and I usually only let it run for, like I said, about 3 minutes. I'll just stop it now. So I would hit stop now and then hit save again. And now it says the capture is ready. So I click on capture, and I'm going to store that on my PC. And it's going to complain that it's not secure. It's like, well, I don't really care. And now I can just click on it, and now all of a sudden here's Wireshark. And this is all the messages on that MSTP trunk. So one of the filters could be I want to do MSTP frame type. And again, we'll get into this next time. And so this is, when I click on that, the only messages that it shows is the token passing. And then what I can do, I could say, and MSTP source equals, and I know my router is MAC 77, hit enter. And now this shows every time the router got the token and then when it passed it on. So this gives you a hint. From the time here, I can calculate how much time is it taking for the token to go all the way around back to the router. So this looks like about 120 milliseconds, which is not bad. But before I, usually before I do that, and anytime you make a change up here in the filter, you have to hit enter. I usually hit info frames, and now I can sort. Here's all the pull for masters, and then here's all my token passing and so forth. And that, I do not have any data requests and replies in here, but you can find those and so forth. So, okay, and then let me see here. If I go here, whoop, now on my Wireshark, I'm just going to start Wireshark. Now this is on my PC, and when you start it, you notice it's starting to kind of give me a little trend line on how much traffic there is. So I double click on Ethernet 3, and now all of a sudden here's everything that's going on, and it's just gobs and gobs and gobs. So it's already, it's only 10 seconds, so it's already 7,000 packets. So I click on stop, my shark turns red, and now I can, for instance, say BACnet. So those are the BACnet messages that my PC can see in the network that's here in the building at KMC. But again, it's only going to show me the broadcast messages because I'm not using Connect at the time. So the only messages that's coming to me are the broadcast ones. What you could do then is use Connect, for instance, on your PCs, start Connect and then do the capture, and then you'll see a lot more interesting messages. And that's really all I have.
Sounds good.
Was that fun? That's usually what I ask my students. Are we having fun yet? They usually say yes. If they want a good grade, they say yes. But.
Right. Perfect. Well, we got a couple minutes left. I don't know if anybody has any questions they want to toss out there. If not, we'll be actually extending our series here. So we'll have a follow-up session here in July. I'm not sure if it's going to be on the 18th or the 25th, but keep an eye out as usual for an invite to our webinar. And as well, we'll work on getting a copy of the slideshow, a link to a PDF copy of it, so y'all have access to the slides. So,
and I guess I just got to end it with it really only takes a little bit of practice for Wireshark to get used to it and that, and it really comes in handy to help you kind of pinpoint where the problem is faster than if you were trying to guess and do this and do that and so forth. It really helps in that regard, and it just takes a little bit of practice, not much. So don't be afraid. It's not rocket science. 95% of rocket science is not rocket science either, but anyway.
All right. Well, that sounds good. Dave, thanks for joining, and everyone, thanks for jumping on and sharing the time with us, and hope y'all have a great weekend, and we'll see y'all next month.
Yep. Thank you.